Hello, everyone, and welcome to the Marshall W. Allworth Planetarium. My name is Jessica. I am the director and will also be your tour guide to the Northern Lights tonight. You've also met Braden, one of our students who works here. So for our show tonight, as it says, we will be talking about the mystery of the Northern Lights. If at any time during the show you need to leave, you are welcome to do so. You would just exit through the same door you came in. Just, of course, be careful because it does get dark in here. And if you have any questions throughout the show, feel free to just ask. I can't always see hands at the back of the computer where I'm controlling things, so if you're comfortable with it, you're welcome to just ask your question out loud. If not, you can always come ask questions after the show as well. All right, I'm gonna head to the back and we'll get started. Okay. So as I said, we will be discussing the beautiful Northern Lights. Now, in general, the Northern Lights appears as this beautiful, dancing, moving curtain of light in the night sky. Depending on conditions, you may see colors like greens and reds, sometimes even blues. Sometimes it's more of a grayish. But what we are here tonight to talk about is what exactly is going on here? How do we get the aurora? Where can we see it? And we'll end with some kind of tips and tricks for you if you want to go out and try and see it for yourself, which I guess that's a good way to start. Has anyone seen the aurora in person? I see a few hands. Cool. Awesome. Well, if you haven't, you're heading into a really good time for them, but we'll talk about that. Now, the Northern Lights, or as we know them here, also as the aurora borealis, that name, aurora, actually originates from the Roman goddess of the dawn. She would ride in her chariot to bring the coming of the light, and so a lot of times poets would use her name as a way of kind of describing, artistically, these lights that they would see dancing in the sky. And we see lots of different names and stories for the aurora depending on which culture you're talking about. When they could occasionally be seen in China, they were described as the great dragons that were battling in the sky. To the Inuit, they are the spirits of our ancestors who are playing games in the night sky. But my personal favorite comes from Finland, where they describe the aurora as the firefox. And so I actually have a really cute little animation kind of explaining their legend behind the aurora that I'm going to show. Okay, so that is the tale of the firefox. I guess I mean tail both ways, don't I? Um, so one of the many, many myths surrounding what the aurora are, how they're formed, and all of that. But we, of course, now know exactly what the aurora are and how they are formed. So let's take ourselves up into space to get a look down at the Earth. So from space, what we see is the aurora is actually a circle. We call this the auroral oval, which is a very difficult set of words to say back to back. And that circle is near the North Pole, although it's not exactly on it because it's actually on the North Magnetic Pole, and we'll talk about why in a minute. And this is our aurora borealis. But if we take ourselves down to the South Pole, we see that there is one down at the South Pole as well, and this is the aurora australis. So we see these auroral ovals around both sides of the Earth, and the size of the oval kind of varies. How big it is, how wide it is, and that can, as that varies, that determines basically which parts of the Earth are able to see the aurora at that time. So then, what's going on? Well, in order to figure out exactly what's happening, we actually first need to talk about the sun, because the sun is a big component of the cause of our aurora. So, our sun, come on, there it is a giant ball of plasma, hot gas, mostly hydrogen and helium. And it has this steady stream of charged particles flowing away from it. We call this the solar wind. And you can kind of see wisps around the edges here. But we have this constant steady stream of charged particles, the solar wind coming out of the sun. How strong it is varies over time. But then we also see that the sun has these loops of gas that pop out at different locations. These loops of gas are what we call a prominence. Now, sometimes the prominence snaps, and in doing so, you can get a solar flare. So this is a prominence that has stretched too far and it snapped, just like if you stretch a rubber band too far. And when it does that, it flings all of that gas and charged particles out into space. So From where we sit on the Earth, we see the solar wind, these steady charged particles being flung at us from the sun. And we occasionally also get bursts like flares or really, really big bursts, which we call coronal mass ejections or CMEs. And that means we have just this steady flow of charged particles heading towards us, towards the Earth. Now, for the most part, we don't have to worry about this because we have essentially a shield. We have a magnetic field that protects us from this steady stream of charged particles. And you can see that it mostly deflects all of the charged particles around and away from us. And there goes our magnetic field, turned visible so that you can see it. So with our magnetic field, actually, let me keep it going and head to, here we go. Back to here, and we can see our magnetic field around the Earth. With this, our Earth essentially is like a bar magnet. We have a North Pole and a South Pole. And while most of the charged particles do get deflected around us, not all of them do. So some of those particles actually get trapped in the magnetic field, and then they are funneled down to the Earth, to where the magnetic field is originating. And so they get funneled either here towards the North Pole, or they get funneled down here towards the South Pole. And as those charged particles hit the gas in our atmosphere, it causes the gases to glow. And it's that glowing that we see as the aurora. So this is why we get two auroras, one near either pole, because that's the two locations that the magnetic field funnels those charged particles. So that's where they're going to hit the atmosphere. Now, I mentioned how these aurora ovals can change size. Let me bring us back up to the north so we can see that a little bit better. But sometimes the auroral oval, I told you that was a difficult set of words to say. Sometimes it's a little bit smaller, but sometimes it can be much bigger and sometimes even wider. This has all to do with how much stuff is being funneled down to hit our atmosphere. On an average day, we just have, say, the solar wind. You get a little bit of charged particles making its way down to the atmosphere. But if we have the occasion where the sun has a solar flare and it's pointed, directed at us, that's going to be a lot more stuff heading our way. And that's going to lead to the auroral oval being much bigger. And that means that you'll be able to see it further down in latitude on the Earth, even say from here or even lower if we got a really energetic one. All right, so these charged particles, they're hitting the atmosphere, they're causing the gas to glow. But where do the colors come from? Because I mentioned at the beginning that you can see greens and reds and sometimes even blues. Well, those colors are the result of which gases in the atmosphere are glowing. The reds and the greens tend to come from oxygen, and the blues, when you see them, tend to come from nitrogen. Now, if you see other colors, like a pink, that's more of just a faint red. If you see more of a purple, then you're getting some kind of reds and blues mixing together. But all of that is what leads to us being able to see some faintly different colors. This is also why, because the oxygen that's creating the greens and the reds, the red happens higher up in the atmosphere and the green a little bit lower. That's why when you see it, oftentimes, like you'll see in here, you'll see some reds at the top and then greens at the bottom. And then as those colors mix together, you'll get other colors seen as well, just from the mixing of the reds and greens and blues. All right, well, before we get into our last section talking about how best to see them, where to see them, let's venture off of the Earth, because you may be curious, is Earth the only place that gets an aurora? Or can aurora happen other places as well? And the answer is yes, they absolutely can. You just need charged particles from the sun and a magnetic field around the planets. So if we head our way over to the largest planet in the solar system, Jupiter here, we have seen aurora around Jupiter's north and south pole, just like the Earth. You'll notice it has more of a blue tint to it. That's because Jupiter's magnetic field is a lot more powerful. And so when the gases, or when the charged particles are being slammed into the atmosphere, it's doing that at much higher speeds. And so that creates light mostly in the UV, the ultraviolet, which we don't see with our eyes. But the little bit that we can see is, in the violet and blue portion of the spectrum. And then if we hop on over to Saturn, we see that it also gets auroras around its north and south pole, just like Earth and Jupiter as well. And both of these auroras on these planets are caused by the exact same phenomena that we have here on Earth. Now, there are other planets in our solar system that do get aurora, although the mechanism is either not well known or well understood. So I haven't put much about them in the show. If you're curious about that, you can always come talk to me afterwards. But for ones that are like the Earth, we have Jupiter and Saturn here. All right, let's head back to Earth and talk about actually seeing the aurora for yourself. So there is a common misconception that the only time that you can see aurora is during the winter. And that is not true. The aurora can be seen all year round. I think one of the reasons that people tend to think it's only in the winter is, one, we have much longer nights in the winter, so you just have more time frame to be able to see them. But also, most of the locations on Earth that regularly see aurora tend to be really near the North Pole, so they have snow on the ground for a very, very long portion of their year, if not all of it. And so the pictures that you see tend to always have snow on the ground. So that leads to this idea that it's only during the winter. But that's not true. You can see them all year round. Now, predicting when aurora takes place can be difficult. Because, as I said, there's a lot of factors that go into the size of that auroral ring, which determines, where on the Earth we're able to see them. We can get a couple of days notice because we see the light from a solar flare before the particles actually reach us. So there are times when we know stuff is heading our way and we can go, okay, in a couple days, we're going to have a really strong aurora. And if you've seen any aurora predictions, that's usually where that's coming from. We've seen some activity from the sun heading our way. So we know it's going to be bigger and more intense. But a good way to kind of keep track of that, there are lots of places online, aurora prediction websites that can give you ideas of kind of what it would be like over the next couple days. If you're local to Duluth, Astro Bob King, on his Facebook and blog always gives updates when there's a good chance of seeing the aurora from here in Duluth. And our social media will always share that information as well. But if you're maybe not on social media or not in the area, there are other ways as well. My personal favorite is a free app on your phone that you can get for your phone called Aurora. Literally what it's called. And this is a aurora prediction app. So it uses your phone's GPS to know where you are. And in the app, it'll show you where you are, where the auroral ring is, and can give you some predictions of what the coming hours would be like. But then my favorite thing is you can set it to give you alerts so that it'll actually send a notification to say, hey, things are looking really good right now. If you want a chance to see the aurora, you should go outside. So it can alert you when chances for your location are getting good. Now, when looking at these predictions for aurora, often what you see is something called the KP index. This is just our kind of scale for how active the aurora is. So it goes from 0 to 9, with the lower number being the less active and the bigger number being more active. In order to see the to see the aurora easily from here in Duluth, we want it to be about a 5 minimum. And then you'll have a pretty good shot if you just get out of the city to be able to go and see the aurora from here. Otherwise, on other nights, you'd have to travel a good bit further north to be able to see that. Now, I mentioned that it can be really difficult to predict when the aurora is going to be good, when it's going to be able to be seen from certain locations. The good news is the sun's activity is picking up. The sun actually has an 11-year activity cycle, and we are heading over the next couple of years into the maximum. So we're going to have a lot more flares, a lot more activity, a lot more chances for strong, intense auroras from here, visible from here in Duluth. So if you haven't had a chance to see it yet, or you have and you just want to do it again, which I completely understand, I want to go see as many times as I can. We are going to have a lot of opportunities over the next few years as the sun's activity picks up. Now, as for seeing the aurora from around here, the biggest thing is you just want to get out of the city. I've had past students who have had luck even just down on Brighton Beach. I know people have gone up to Hawk Ridge and seen it. I personally, when I saw it last time, we went down the scenic highway about maybe 20 minutes and pulled off on one of those little outlook pull-offs, and had absolutely gorgeous views. Like, you really don't have to get too far away from Duluth. You just need to get out of the main city, and you can hopefully see some good stuff. Now, speaking of seeing the aurora, I do have to mention that what you see with your eyes is not always what you're going to see, or is not always the same as what you might see in pictures. That's because cameras are more sensitive to light. They can collect more light than your eyes can. And so what you see may not be quite as bright or quite as colorful as the pictures of the aurora that you may see. So I don't want to, this is basically, I don't want you to like become disappointed if you're not seeing these super, super vibrant colors. Most of the time it's going to be a bit more muted. You may not see bright colors, you may see tinges, but it's probably going to be more on the gray side. But when it's really intense and really active, you can see those colors in there. All right. And lastly, if you are wanting to go aurora chasing, to get out and go see the aurora when it's happening, in addition to the resources I already told you in the app, we actually have a project that we have partnered with the Chickawauk Museum and Nature Center up at the end of the Gunflint Trail. We have a all-sky camera sitting on the top of their museum. And the feed from that camera, you can find it on our website. And it takes basically an image once a minute all night long. And so a lot of people use that as a way of just kind of seeing what conditions are like, seeing if you do get, if we are seeing aurora out. And then the benefit to this is at the end of those nights, we create a time lapse of all of the pictures that were taken that night. So this is the time lapse from that night back in March when we had really, really strong auroral display. So again, this is up at the end of the Gunflint Trail over the course of the night. And this camera you can always access from our website. We also have a Facebook page for the camera that you can follow to see these nightly time lapses that we compile every day. But it's also just stunning. Like, I couldn't do a show on the aurora and not show you this time lapse because it's amazing. And this was the night that my husband and I went out that I mentioned. We were just like 20 minutes down the scenic highway, and we could see it all to the eye, dancing, moving around, curtains of light. It was spectacular. All right, and that brings us to the end of our show. So hopefully you all enjoyed learning about kind of what causes the aurora, and we ended with some locations and tips and tricks for you. I'm going to bring the lights up just a little bit and see if there are any questions. No? Let me check online real quick. No? All right. Well then, yes. Basically as far north as you can get. I know so this camera, or the camera I showed you, is up at the end of the Gunflint. And it's, especially right now, is seeing aurora pretty frequently. But yeah, it's trying to get as north as you can, unless you know that we have a really big event coming in that's going to be easily seen from here in Duluth. Yeah. Is what? It's right on the edge. So it's right next to the Boundary Waters. Yeah. Yes. Say a little bit louder. Oh, it doesn't have to have any temperature. Yeah, it can happen any time of year. Yeah. All right. Well, I will still be back here if you have any questions. Otherwise, thank you so much for joining us tonight. Thank you. As you head out, we've got some star charts out in front of the table, on the table in front of the TV, if you'd like to take one with you. Brayden will also be passing out eclipse glasses because we have a solar eclipse coming up on October 14th. So take a pair of eclipse glasses so that you can safely watch that for yourself. We'll also be doing a viewing party here at the planetarium that day as well. It'll be that morning. So yeah, again, thanks for coming and have a good rest of your week.